what is carbon fibre and what makes it so ideal for motorsport applications?
Yeah, so the material properties of it likens itself to being a high strength to weight ratio. That's the real ultimate. If you're perhaps in a hobbyist sector and you're not necessarily using the craziest engineering or whatever behind it, there's no reason why you can't achieve good results with other materials in a much cheaper way.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Keith Peden from Rodin Cars right here in New Zealand. Keith is heading Rodin's composites department, and composites these days are just about everywhere in the world of performance motorsport, but I think it's still an area that, at least at the enthusiast level, there's maybe a little bit of a lack of understanding and knowledge around, so we're here to try and put that right. I think composites is also something that has got a relatively low barrier to entry for the average home enthusiast to get out there and actually start making their own composite parts. Now, I'm not talking here about prepreg parts that are cured in an autoclave, obviously. That's another level again in terms of complexity and also cost. But at least making parts in fiberglass or carbon fiber, particularly wet layup, this is absolutely within the wheelhouse of any average home enthusiast with a little bit of time and attention to detail. So we talked to Keith about what the term composites even means, what the different options are in terms of composite materials and the pros and cons of each. We talk about the different ways that we can actually make parts in terms of wet layup. We talk about resin infusion, vacuum bagging, and also prepreg, which I've also mentioned, and where each of those sort of fits into the industry and pros and cons of those techniques. We also talk about mold making and what's involved in that, and essentially the life cycle of a part, so from design to actually prototyping and making the finished part, what all of that looks like. So anyone who's interested in composites and maybe has a craving to start making your own parts, there's a lot of detail in this podcast that I know you're going to love. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place, and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes, and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Keith. Thanks for joining us. And as always, let's start by diving a little bit into your background and specifically how you got an interest in cars. Or do you even have an interest in cars? You're working for Rodin Cars, but yeah, let's find out.
Well, thank you for having me. So, growing up as a young fella, my family were always into cars, so I've always kind of been exposed to it, and going to motorsport events on the weekends and working on the cars in the shed. Yeah, so it's been with me for a young age, and yeah, I've always kind of wanted to go in this kind of direction.
So composites is a pretty specific direction, obviously also far from being exclusive to the automotive scene. So how did you pivot towards becoming a composite specialist?
Well, I had some pretty lofty goals, I guess, when I was younger. I wanted to get into like car design and stuff, but then that switched into like motorsport and whatnot. But the opportunities in New Zealand started to, well, they weren't really there.
Yeah, I don't think they've ever been here in New Zealand, unfortunately. If you want to make it, you kind of have to go overseas at some point.
Yeah, or change your strategy, and that's kind of where I ended up going. I wanted to still, be on the pathway to do something special in the automotive space, but that's kind of where I started to lean towards going into the trades, and I saw the composite sector as something that I'd like to get involved with. You see cars at the racetrack, that kind of inspired me that's somewhere I could kind of get into. So.
All right, so I guess that begs the question, how does one become qualified or trained in composite manufacturing?
There's a few different pathways. Depends on where you are in the world. Your opportunities will change a lot. But in New Zealand, we've got there's a couple of options. Probably the most common thing that you'd come across would be like people from the marine sector. The boating is pretty big. We've got a lot of water here, like the America's Cup, and there's a couple of other boat manufacturers as well. So that's pretty popular. But the route that I went for was through aviation. So I ended up doing my trade apprenticeship through the New Zealand Air Force, and I spent a bit of time there and took on some skills from that. And there's a couple of external providers as well that I went through.
Okay. Let's just sort of talk about this trade here. So are you saying that composites as an industry, it's essentially becoming a composite specialist is no different to becoming, let's say, a mechanic or a builder or maybe an electrician, where you've actually got a apprenticeship program that you go through? I guess that involves some classroom work and then some practical work under an employer. You do your hours and you come out the other end with a piece of paper that says that you are a composite specialist. Is that kind of how that works?
Yeah, I would say so. I mean, that's been my pathway through it. I think there are a lot of people that have gone through perhaps a less traditional way, just picking it up on the workshop floor or, doing it at home or whatever.
I guess from an enthusiast perspective, self-taught, learning from the resources available on the internet, etc., is viable for maybe making your own carbon fiber parts for your race car or your project car. That wouldn't be enough though if you wanted to get a job at, say, Team New Zealand or Rodin Cars.
Well, it's certainly in modern day. There's so much more stuff online that you can learn from, which is awesome. People perhaps haven't been as forthcoming with information about this stuff because it has been in quite high-tech sectors and stuff.
I guess what I'm saying there is if you're a home enthusiast, self-taught, you can make your own carbon fiber parts. Maybe you know how to vacuum bag and you know about resin infusion, that sort of things, all terms that we're going to talk about as we go through this podcast. Would that be sufficient to rock up to Team New Zealand? For those who aren't aware of who Team New Zealand is, that's the America's Cup team. That wouldn't be sufficient to rock up to Team New Zealand and apply for a composites role, or would it?
Certainly, if you wanted to go down the apprenticeship route or whatever, like going in there with a keen understanding of some stuff and the willingness to learn and whatnot, I don't think you're going to go in there and run the shop. It gets your foot in the door. There's just like any other trade or whatever, you might see a YouTube video or whatever, and that might show you the ropes, but the background, like the husbandry of the actual doing the work, there's a lot of not so glamorous stuff that you won't see on a YouTube video.
Yeah, I think it's always frustrating as well with any of these skills that require an understanding of the principles of what you're doing, but then the actual practical application of those skills. And it can be a little bit disheartening, I think, when you watch the video and the person demonstrating everything, it just all goes seamless and the part pops out of the mold and it's absolutely beautiful, requires no sort of post-processing. And then you try and do that yourself and you end up with a hot mess that's pretty frustrating. So I think it's important to know that understanding the skills, the principles and the practical skills is critical, but then obviously there's also the application, just becoming proficient, just doing the job. And the old saying, it takes 10,000 hours to become an expert in any field.
Yeah, that's the thing. Yeah.
All right, coming back to your sort of apprenticeship through the Air Force. So how long does that apprenticeship in composites sort of take to complete?
I'm a bit of a weird case because there was a restructure during my career, but I was an apprentice for probably about 18 months. I went through a series of trade quals. It was kind of streamed alongside the aircraft technician trade at that time. So there's lots of, I guess, the way that, you're interacting with aircraft in the workshop and to develop a base skill. It's not necessarily just going in there and doing the composite element of the job. That's the thing, is it's interacting with all the other stuff that is, part of the background of it. But yeah, that was that was geared towards the lower tech end of the spectrum as the junior trade. That was kind of covering off on some of the like mold making techniques, working with predominantly with fiberglass at that stage, and doing repairs, like running repairs on things on base, and not necessarily getting aircraft level work, but like just supporting the rest of the equipment. Because, the materials are used very widely. It's not necessarily just like super techy stuff.
Sure, yeah. I mean, probably worth giving a bit of an understanding of the level of New Zealand's Air Force to the rest of the world. Could you give us an idea of maybe how many F-35 Lightnings New Zealand has in its fleet?
That'll be zero.
Zero. Okay.
Yeah.
F-18s, about the same? Zero?
About the same. Yeah.
Okay, so no fighter jets is what we're saying here.
No.
All right.
Very peaceful nation.
Enforced by our lack of budget, I suspect. But I don't know if anyone's going to be coming to take over New Zealand anytime soon anyway. All right, so I mean, on that basis, basically what I'm getting to here is we don't have a fleet of high-tech fighter jets. What is the use case for a composite repair inside of our Air Force? What are you actually fixing? What are you making molds of?
Composites has been involved, but has been a part of aircraft manufacturing for many, many years. So like even the older stuff, everything post World War II, but the older stuff in the fleet might have been from the 60s, like the Hercules designs and stuff like that. So there's still composites there. The more modern aircraft in the fleet, like there's the full composite airframes in the NH90, which is a medium-sized helicopter. There's plenty of work there, but the day-to-day, I guess, is just to keep them alive. There's always like routine servicing, and thankfully not in a war zone very regularly, so there's not so much battle damage, but there's definitely wear and tear.
Okay, I would have assumed that outside of combat where time is of the essence, that repairs would really involve ordering new parts from the manufacturer rather than actually remanufacturing them yourself or repairing them?
Not necessarily. So New Zealand does have a pretty tight budget on things. And also the lead time for some of our equipment is ridiculous. So there are opportunities to make things work.
Okay.
And there's varying degrees of like making up these molds and whatnot that you're not necessarily, that can be part of a repair process too. It's not necessarily, you're not necessarily remanufacturing a component. So these skills kind of do get used across a wide set of areas.
Okay. So at this point, you've got your apprenticeship completed. And what happens after the Air Force?
I ended up having to retrain because of the restructure, but I spent some time as an aircraft technician, about 3 years there, and for that time I was on squadron working on the NH90 aircraft itself without the specialization, which is cool. That's just like flight line maintenance and minor servicings. But then that wasn't really where I wanted to be. It was good to pick up the skills, but I went back to the composite specialization when that opportunity come back. So from there I did my a senior trade qualification, I suppose you call it, and I had another period of, I guess you call it an apprenticeship in the workshop before I was deemed to be fully qualified in there. So
sorry, is this a further specialization within composites?
Yeah. So it's a little bit back and forth, but the way that they had previously run it is that there would be a junior trade training and a senior trade training, and after you'd completed your senior trade, you'd be let loose really, and that would be openly into the aircraft repairs. But that then I was fully qualified there.
Right. So you've had an unusual path, I guess, through the Air Force. What brings that chapter of your life to an end?
I kind of got bored, I suppose. I feel bad saying it, but there wasn't. I got plenty of training and support, and it was fantastic. But there just wasn't really the work coming through that, I wanted to do some crazy stuff, and wishing that you get in the situation where there's crazy stuff to repair is not necessarily ideal. So I went out and found something to build.
So basically they weren't breaking these aircraft often enough for your liking.
No.
Okay, that's a double-edged sword, but I get it.
Yeah. And then that's what led me down the pathway of looking for some different work. And I considered a few options at that stage, but the opportunity to go to work for Emirates Team New Zealand came up, so I gave that a go.
All right. So what was your role with Emirates Team New Zealand?
Just as a laminator, I suppose you'd call it. Perhaps did a few different minor tasks either side of that. That was my primary role. The way that the boat was constructed, is that the major component being the top and bottom of the hull. But there was a series of bulkheads and stringers and stuff that ran through the structure, and I was just in the shop working on those. So, and they're pretty significant parts, but just big, large sandwich panels with different hard points and things in them.
Okay. In terms of the design of these America's Cup racing catamarans, where obviously they're very much on the absolute edge in terms of the strength versus weight. So could you give us some insight into how those are designed before it comes to actual manufacture? So how do they go about designing something that they know is going to be fit for purpose, but not with a safety factor that just ends up making them massively heavier than they need to be?
That's a good question. I didn't have that much of an involvement with the engineering side of Team New Zealand. Just, the drawings come through and we go from there. But I'd imagine there'd be quite a lot of modelling, especially with all of the hydrofoils and stuff like that.
Yeah, there must be some insane loads on all of those components, I would think.
Yeah, it'd be ridiculous. I couldn't speak to too much of the technical stuff of it. That's a little bit outside of my scope.
Okay. And how long were you working at Team New Zealand for?
That was about 9 months. I was still employed by the Air Force at that stage, so I went back to my old job after a while. So,
all right. Gives us a pretty good understanding of your background and how you've built up this skill set. So let's sort of move on to modern times. You're now working for Rodin Cars in North Canterbury here in New Zealand as a lead on the Composites team. I think inside of New Zealand, it's probably fair to assume that most people who are interested in cars probably have heard the name of Rodin, but even aside from that, most of us probably don't really have a good understanding of what Rodin Cars is. So could you start by giving us sort of a high-level view of Rodin Cars? What's the business about? What's it producing?
Yeah. So we're a small vehicle manufacturer in North Canterbury. We've recently, been going into pretty high-end sports car manufacturing. One of our previous products was the FZ, which used to be the T125 Lotus program, and then we built the F0, which is our company founder's. That was kind of his goal of the business. And recently, we've done the Centura, which is a reimagined GT1 race car. But we also have our own power plant that we manufacture in-house, which is called the RC10, which is a V10 engine.
Yeah, I had the pleasure of interviewing someone from Rodin Cars at World Time Attack last year about the RC10, and at the time I was blown away. It's a pretty bold direction to go in to make your own bespoke V10, but here we are, and it's up and running and it works.
Yeah. We've always had some pretty lofty aspirations, but we're trying our best to get there. Both the F0 and the Centura are powered by an RC10. We've got the turbocharged configuration in the F0 and naturally aspirated in the Centura.
Okay. Let's back up a little bit and we'll start by talking about the FZ. So as you mentioned, the defunct Lotus T125 program. And as I understand it, Lotus basically developed this as you pay an exorbitant amount of money to Lotus. You own a car, but kind of don't take delivery of it, and then you turn up to a racetrack with your race suit and your helmet and drive around and then go back home at the end of the day. Is that sort of...
Yeah, I think that's the kind of general vibe of it, yeah.
So it didn't work for Lotus. Do you sort of know what went wrong there?
I'm not sure. The theory could be that it's perhaps a bit intimidating. It is very fast, certainly not a slouch. Yeah, I'm not sure what the deal is there.
I guess that begs the question, what did Rodin Cars see in that project that they thought they could do better than what Lotus had done?
I'm not sure on that exactly. I say this is a little bit before my time, but there was there's a couple of improvements to it, and there was still chassis that hadn't been built. So we had a mule car that became David's car. There's a few different modifications that were done to that, and that was rolled out onto the other chassis.
Right. David, just to be clear, is the founder of Rodin Cars, for those who aren't aware.
Yeah, that's right.
Okay. So you've basically built up a dummy car, a mule car, and then gone about developing improvements for that to apply to the other chassis.
Yeah.
And how can you give us an idea how many of these FZs are there in existence?
I think there's 5 of them.
Okay. And in terms of, again, just so we can get a bit of an idea of it, in terms of power, weight, etc., where do these sort of sit in the realm of open wheel wings and slicks race cars?
They're right up there. I mean, they're just over 600 kilo dry, and I think it's about 700 horsepower. Off the top of my head, I need to double check that stat.
That's pretty healthy though, and Cosworth V8 from what I understand.
Yeah, yeah.
Okay. Can you give us a bit of a sort of an understanding of what improvements Rodin actually applied to the chassis of the cars? What you actually found was sort of lacking or needed improvement?
Yeah, I think there was a lot of work was done on the suspension system. They went from a different to a different setup altogether there, and a heavy use of titanium, 3D printed parts on the car, and titanium fasteners. So there was a lot of weight pulled out of it through that. There was a few, I think, overheating issues with the cowlings and things like that. So
yeah, if I remember correctly, the engine cowling would catch fire if you sat there idling for too long.
Yeah, that was a neat trick. Yeah, so we solved that, but it's fundamentally pretty similar, but just a little bit polished up. Yeah.
All right. Let's talk quickly as well about the F-Zero. As you mentioned, this is the founder's sort of vision for the company to start with. And I mean, it's a pretty bold claim, but he's put it out there publicly. Basically wanted to build a car that's going to end up faster than a Formula One car. Now, when I hear a claim like that, straight away, it immediately makes you skeptical. It's a very bold claim, but also if you want to sort of reach for the stars, you need those sorts of claims. Can you give us a bit of an understanding of whereabouts that car is in its development cycle at the moment?
Yeah, it's still quite early in its development. We've had the car up and running a couple of times now, but we aim for the stars. And every time we go out there, we break something or find something else new that we need to remedy. So slowly getting quicker or more reliable, perhaps. And yeah, I'm sure we'll get there eventually. But say this is it's David's passion to get that car running. So yeah, we've just got to keep chipping away at it.
I think everyone needs a passion project. Again, not to get too far off track because we're here to talk about composites, but I think it's also important to get a more thorough overview of what's going on at Rodin Cars. When you're looking to build a car that's going to be faster than a Formula One car, there's a few sort of aspects to that as I would see them. One is power, but I'd sort of almost think to myself that's probably the easiest of the metrics to fix to get. We can make power, albeit we also want to make power in a lightweight, which is the other metric we need to consider for performance, getting the weight down. Composites obviously plays a big role in that as well. And then the other part, which seems to be increasingly critical in getting performance out of these very, very fast cars, is the aerodynamics. And we look to Formula One, albeit they are very, very restricted by the rule book. You've obviously also got some of the smartest aerodynamicists anywhere in the world working inside of these Formula One teams. How does still, I guess, a relatively small company from inside of New Zealand, the middle of nowhere in terms of motorsport development, how do you kind of leverage the aerodynamic skill set to work at that level?
Yeah, well, for the F-Zero, for example, that's predominantly driven by David himself, and he'll have things that he wants to try out, but if the skill sets aren't in house to perhaps critique those things, we'd look at consultancy, because say you still need a bit of help every now and then.
Yeah, and I think it's important to mention that there's a lot of ex-Formula One aerodynamicists, such as Kyle, who we've had on the podcast before, who have moved from the likes of Mercedes AMG F1 and now offer exactly that, consulting services to both club level races as well as OEs and race teams. So that's out there. All right, the last one that you mentioned, the Centura. So a reimagined GT1 race car. So that's a mouthful. We don't have pictures on an audio podcast. So give us a better understanding of what that actually means.
I think it's just batshit crazy race car from the 90s. It's pretty sweet. That's not very technical, is it? No,
it is a very good looking car, and I suggest that people go and have a Google so when they know what we're talking about.
I guess to the way that I try to describe it, I suppose, is that you imagine the field that it was running against. There's in the late 90s, it's the height of the really interesting supercars that were still resembled a road car that went racing. So the likes of the McLaren F1 and the Mercedes CLK GTRs and 911 GT1s and things like that. And this is kind of in that type of category. It only ran in the British GT1 series. So there was a few different lower budget companies or builds that entered the fray there. So this kind of falls into that category. So originally back in 1999, they only built the one car, and there was aspirations to build some more. But long story short, David bought this car and a spares package 20 odd years ago, and it's been sitting dormant for a long, long time. So using the spares package, we built a second car and have powered it by our engine, and there's a few other pieces that are custom to Rodin as well. So.
Okay. And is the intention to design these, or sort of, I guess, more to the point, manufacture these to order? Or is it you've got the two cars and there's no more after that because there's no more spares package?
There's still the opportunity to do that. That's something that we have always kind of said, is that, we could make one to order. But what's more important to us is to utilize the second Centura as a development vehicle for both the engine and chassis development, continue on to the next vehicle programs.
Okay. Again, I wanted to get that backstory on Rodin, so everyone's got a bit of an understanding of a company that I would imagine most of our listeners don't really know what it is, or what you're producing. If you're a fan of the podcast and you're interested in topics like engine tuning, automotive wiring, performance engine building, 3D modeling in CAD, or anything else in the high-performance industry, I have something that you might be interested in. Introducing the High Performance Academy VIP package. This package of courses gives you lifetime access to all of HPA's online training for one price. These courses cover everything from tuning and reflashing petrol and diesel engines through to motorsport wiring, engine building, fabrication, design, car setup, and plenty more. Right now, you can get $500 off High Performance Academy's VIP package using the code PODCAST500 at checkout. Becoming a VIP means you'll never pay for another course again. You'll get instant access to all 40 plus courses we currently offer, plus every new course we ever release in the future. Want to define maps or tune with WinOLS? Curious about CAN bus devices, or how CAD can help make your dream build a reality? These in-depth topics, as well as many others, each have their own dedicated course that are going to help you master whatever it is you want to learn. And as a VIP member, you're not just getting the courses, you'll also join HPA's online community with lifetime access to our member forums and members' webinar lessons. Again, the code is podcast500 for that $500 discount. Just head over to hpacademy.com to check out the full VIP package and everything it contains. All right, let's get back to the episode. So let's get into composites. So can you start by essentially giving us an understanding of your role as a composites team leader? What does that actually mean, and what's the sort of the average day in the life of Keith look like?
So I guess as the workshop manager, I kind of consult with the engineering staff and take on jobs, depending on the workflow of the life of the job. There might be a few tweaks here and there, or that might just get commissioned straight into the workflow, managing staff. And I've also, in recent times, started to do some more work in the workshop myself. So it's quite a broad.
Quite varied.
Yeah.
You just mentioned managing staff, and one of the questions we didn't sort of get an answer to earlier, how many staff are there in Rodin Cars?
About 30 at the moment.
Okay, it's a pretty big operation then.
Yeah.
Right, so you're sort of working after a part has been designed through the sort of engineering design team. Is that's what I'm picking up? So they'll design a part that needs to be manufactured, and then your job is to take that part from their design and produce a finished component that can go on a car?
Yeah. There are, opportunities to be involved earlier in the process, because perhaps some techniques may be able to be, changed a little bit. Or
yeah, I was interested in that aspect of it in terms of the interaction between the composite side and the design side, because almost irrespective of the manufacturing process, whether we're talking about CNC machining or composite manufacture, there's the ability when you fire up Fusion or SolidWorks, you can design and draw up something that looks pretty, it's going to be perfect for the application, and then you realize that there's actually no practical way of manufacturing it.
Yeah.
So first of all, do the engineers that are doing the design work, do they either have a pretty good understanding of composites manufacturing, or do they sort of go backwards and forwards with you on what needs to be done to actually produce a part that's going to work for their design aims, but also can practically be manufactured in the real world?
Not always, no. Sometimes we butt heads. We're pretty lucky at the moment. We've got a couple of really clued up guys that have done a lot of practical stuff themselves in the past, and that has really come through. It's not always straightforward, and sometimes you do have to go back to the drawing board altogether. Like choosing, say, carbon fiber is the best. It's not always. There's still plenty of other options, and I don't mean carbon fiber just within the composite space. Like, sometimes it's just better to make something out of metal or 3D print it,
I think these days as well, with the advent of 3D printing and 3D printing of metals, there are now so many choices as to how to produce a finished part, and maybe it's not always cut and dried as to what's going to be the best. I guess the answer to this question is going to be completely varied, but just for our listeners to give them some idea, could you let us know maybe what a feature might be that you could draw in SolidWorks or Fusion that would be very, very difficult to actually make the part as a composite component?
Yeah, I mean, tight radius is just a simple thing, like if you were to look at anything that you perhaps interact with on a daily basis, like molded plastics or whatever, there are actually always radiuses integrated into it and tapers, so that you can release it from the tooling. And you see these things, you don't really think about them, but like that's pretty much the bread and butter of how to get any molded part up, disassembled off the mold.
We call that draft angle, am I right?
Draft angle, yeah. And the draft is a big part of it, but also, yes, the features, the fine features, where if it's like got hard square edges and stuff on it, that can be very difficult to lay up into. And often you get like resin pooling and things like that if you can't get placement correct. All right.
Okay, so let's get into composites a bit deeper now. And I think I want to start with that term composites. What does that even mean? I think it's thrown around a lot without maybe a full understanding of what it's actually referring to.
Yeah, I guess it's a combination of two or more materials, which will have properties of both of the base materials existing in the final product. And like in a very simple explanation of that could be, concrete. It doesn't have to be high tech. It exists across all the sectors.
I think that was kind of what I wanted to get to, is when we use that term composites, it's not actually just sort of limited to the motorsport field, is it?
Oh, no, not at all. But I mean, yeah, if you were to look at it in the say, carbon fiber manufacturing, you'll have the dry fabric itself, and then that will be supported in a matrix of resin.
And the idea behind this here is you're sort of getting a synergy where you're getting the finished part has properties that are superior to the individual components themselves.
Yeah, that's right. So I mean, you think about it in a very simplistic term, the fiber could be a rope. You can't push a rope, but you can pull a rope. And the resin is, gives it a compressive strength and supports the fibers in an orientation so that they can transfer the load.
Okay. Let's talk a little bit more about that before we jump into the individual materials. You've just talked about compressive load versus tensile, where the rope you can pull it and it's going to be strong, but you push it and obviously it's a wet noodle. It does nothing until you put that rope in the resin matrix. In terms of designing a part out of composites, is there some design considerations we need to make in terms of optimizing the design of the part for the strength, or how the composite component is going to be strongest? I don't know if I've explained that very well. Basically, is in general, if we're making a part out of carbon fiber, is it stronger in tensile or compressive load?
Yeah, I think I've got your question there. So yeah, you can. I mean, one of the great benefits of it is that you ultimately can tailor your characteristics of the component through fabric placement in a multitude of ways. So it does perform better in tension. So like if you were perhaps apply a scenario to what you're talking about there, like, if you had an aerofoil wing section on the back of a race car, it's going to be trying to bend. So like if you were to load a dominant fiber direction that ran lengthwise across the car, so that as it's pulled down, it's going to be, the fiber orientation is going to be aligned with the way that the component is loaded. So is that kind of where you were getting at?
Yeah. I think that's pretty much what I'm getting at.
But you wouldn't just have fiber orientated in that way, So you'd have all sorts of fibre orientations in there.
So generally we have a weave where the fibres are running in two directions at 90 degrees, but they're not always limited to that either. So you can actually choose a weave and then orientate the way it's laid up in the mould in order to optimize the strength for that particular application, correct?
Yeah, that's right. So there's lots of different fibre weaves and methods of laying them. You can just have a unidirectional fibre which has no other fibre direction to it at all. Or, you might see commonly like just a plain weave which just looks like a checkerboard or a twill or something like that. And they all have different characteristics. Some of the more higher end stuff you see like harness fabrics as well. So yeah, it's all different.
Okay. Right, let's move into the materials themselves. And I think when we talk composites at a motorsport level, people straight away jump to carbon fibre. That's not the only material by any stretch of the imagination, but let's start with that because it is so popular. So what is carbon fibre and what makes it so ideal for motorsport applications? Or many motorsport applications, maybe not all.
Yeah, I mean, I guess it's no different to any other textile in the composites space. The material properties of it likens itself to being a high strength to weight ratio. That's the real ultimate. If you're perhaps in a hobbyist sector and you're not necessarily using, the craziest engineering or whatever behind it, there's no reason why you can't achieve good results with other materials in a much cheaper way.
So it's not the be all and end all.
It's not the be all and end all. I can understand why that, in the high end stuff space, you're chasing it.
I think probably in the enthusiast market we see its use in Formula One and also high end supercars and hypercars. Carbon fibre has become more and more thoroughly used in their manufacturing. So I guess that's why we see that as being the sort of the pinnacle of composites. All right, let's move on to some of the other materials. Kevlar would probably be another one that is commonly used in motorsport. So what is Kevlar versus carbon fibre, and can you let us know what the relative pros and cons of that material are?
Yeah, so Kevlar is often used in like an abrasion resistant, for its abrasion resistant. So you'd see it in like underbodies or perhaps wheel guard liners, splitters, things like that, where you're going to see some wear. It doesn't have the same strength characteristics as carbon fibre. You also a bit more flexibility, which works to its favour here. I mean, if it's too brittle, like carbon can be, I guess you would characterise as a little bit more brittle. If you're going to be taking a bit of abuse, some rocks or whatever in the underbody, like it's good to have a bit of flexibility there.
Very prominent for manufacturing underbody protection for the likes of rally cars, where the whole underbody is consistently getting pelted with gravel, sort of rocks and stones, correct?
Yeah.
All right. So in terms of that flexibility, would that make it also kind of ideal for the manufacturer of body panels, where maybe you can have some contact with another car and it's not necessarily going to crack and break?
Yeah, it would fall into that as well. You do see that occasionally on race cars. And then I guess that going back to the budget end of the spectrum, there's a lot of fiberglass has that same, not so much in the abrasion, but the flexibility and the ease of repair and all that. You'll see that a lot in club cars or just anything really with custom coach work.
Okay, so in terms of those three that we've just mentioned, carbon, Kevlar, and then fiberglass, could you give us kind of a scale of cost for those three materials? Obviously, we've got fiberglass at the bottom of that spectrum. I'm going to assume here that carbon's more expensive than Kevlar?
I think you could generalize it and say that in the per unit cost per square meter, that fiberglass starts cheaper and carbon is generally the end of the top of the line, but it does vary a lot. There's a lot of overlap there. You can actually get some really high grade fiberglass. People might generalize it fiberglass and be like, just chop strand mat or whatever, but you can get some really quite trick wovens and prepregs as well in fiberglass.
So it's not exactly black and white as to where that cost is. With those higher end fiberglass options that you just discussed there, I'm guessing we're still well below the strength of carbon fibre.
Again, not always. There are definitely differences in quality on the market. You can still get aerospace grade fiberglass,
What it's sounding like to me is that there's no black and white here, lots of shades of grey, which then my next question is, that's all well and good. So with all of these options on the market and a lot of overlap in their properties, how on earth do you decide what the best material is for a given application?
Yes, that is the question. A lot of testing and a little bit of research into what you really want to achieve. With so many options, it's not just the fabrics. There's we haven't gone to resins and all whatnot. I guess like you'll encounter so many different options, and everyone will have a different opinion on things. You kind of just got to lock something in and then go for it, because the whole way through the process there's variables, and you got to start just eliminating some of those. So choose something that I guess fits your budget and fits your where you think you want to go. I guess the other parts that we haven't really talked about, well, will lead into it, but processing methods. Like if you want to get a super high performance product at the end of it, you're going to have to go for the high performance product the whole way through, by choosing the correct materials and tooling methodology and all that kind of stuff. So I guess having a little bit of an appreciation for the whole scope of works.
It's going to allow you to choose the best option for what you're trying to produce, and I guess your budget and access to the required processing options.
Yeah.
A couple of other terms that you've used there that I just wanted to dig into. So you mentioned chop strand mat, which I think, at least in the enthusiast market, is probably what people think of when they think of fiberglass. Maybe a cheap body kit. Then there's woven mat as well. Can you explain the pros and cons of each of those?
Yeah. So I guess if you were to make a generalization on the chop strand mat, that can exist with a fiberglass and carbon as well. But you might be talking about like just randomly orientated fibers, perhaps a couple of inches long, that are just blended together in this big mat. And the strength characteristics of it are not great, but it is incredibly flexible once it's wet out, because it's not held together in this like controlled form like you might get with a woven structure.
So easier to kind of force it into some of the more intricate shapes on like a body kit, say a front bumper, for example.
Yeah, exactly. And there's another side to that as well, in that you'd see in the commercial sector, you mentioned the body kits or whatever, but also like large industrial scales too, where you can use a chopper gun, which is basically the filament would come out with a mixture of resin and be sprayed onto the mold. I mean, I'm sure you would have encountered this before with a lot of the other stuff you'd see, just around. It's not necessarily all manufactured by hand, and that material type lends itself well to that type of thing.
So, what could you give us maybe an example? Were we talking about that in maybe boat building or something like that nature?
Yeah, things like that. But
you sort of insinuated there it can be like robotically controlled, sort of automated.
It could be, but I mean, I think in most sectors it's probably just some dude. But yeah, those technologies could, fabricating a body kit on the weekend or whatever, it's all achievable there.
But ultimately, very flexible, easy to work with, but not a lot of strength.
Yeah.
That would be the easy way to summarize chop strand mat.
And not as controlled. Well, it's one of the least controlled methods of wetting out with resin as well. So you're going to get a lot of weight.
Okay. So great for applications where we're not worried about the weight.
Yeah, exactly.
And it doesn't have to be too strong. Okay, so woven mat. Give us a bit of an understanding of that. And I guess most people probably this is what they would think of when they think of carbon fibre.
Yeah, the likes of your plane weaves, twirls, whatever, and unidirectionals, you get the ability to tailor the strength characteristics of your product to a much greater degree than you would if you had randomly orientated fibres. And that's where you start to see the high performance stuff come into its own.
But again, that woven mat is not the exclusively for carbon fibre or Kevlar, as you mentioned there. There's some high performance woven fiberglass as well.
Yeah, that's right. Yeah.
Right. The last one I wanted to bring up, which seems a little unusual, but I believe it's becoming quite popular, is the use of flax.
Oh, yeah.
Which we wouldn't really think of as a composite material in the motorsport industry, but I'm not sure if you've been involved with using flax composites, but how's that come about?
Yeah, one of the things that people are becoming more and more aware of in the world is, just the environmental factors. And composites isn't exactly the cleanest, greenest thing around. There's a lot of waste. So there is a lot of initiatives there to start to use some more natural fibers and products there, and recycled products as well. But with the flax, there's some initiatives that have been put forward to start to use those in some race series, I believe, as like a way of softening the impact a little bit. But I haven't had much experience with the the flex myself yet. I know there's a company in New Zealand that reached out about it recently, but waiting to see how that one unfolds.
I guess sufficient to know that it actually exists anyway.
Yeah.
All right. Now that we've got a basic understanding of the materials, I think it probably also makes sense to talk about the other part, which is the resin. So, what is resin? What's available? And are they all created equal?
Well, I guess there's a few different types there, depending on the materials and systems that you want to go for. But predominantly, you would hear the term epoxy resin. Other common terms you might hear in this industry will be like vinyl ester and polyester. That's commonly attributed to probably lower grade stuff. And then there's also some other like space age stuff that's starting to come into the mix. But so many different products out there.
Well, I guess let's start with the fact that for those who are completely new to all of this, these come as a two-part mix that we combine and then mix together, and that's when it starts to harden. Is that across the board for these resins, or are there some that are a one-part mix?
Yeah, I mean, you're on the money there. You've got two relatively inert substances, and then you mix them together, and then it becomes a solid.
How critical is the sort of mixing in terms of the quantity of the two parts? And I see videos of people working composites weighing out the A and B part of their resin. How critical is getting that absolutely spot on? And then also, how thoroughly do we need to mix all of this to make sure that they are actually mixed properly?
So best practice is to get it as close as you can, especially when you're working with smaller quantities. A small deviation can be enough to change the mechanical properties of the resin. And perhaps the nature of what you're doing, you might not necessarily be able to test to see if there is actually a difference in what you've done. So
you could potentially end up with a part that's not as strong as you think it is because the epoxy hasn't been mixed properly, or the resin hasn't been mixed properly.
Yeah, 100%. So we kind of touched on it before, but like the husbandry of your trade practices and having a consistency in how you approach things, definitely using scales or some method of maintaining consistency and accuracy when you're weighing out your product, mixing it together thoroughly. You'll encounter lots of different products. Some of them, be thinner than water, and relatively easy to mix through, but others are like very, very thick. And, it does sometimes take a lot of time, and people often overlook mixing through things properly. And there's an opportunity to mess the job up at every step. So,
of course. Just like anything, I guess. In terms of working time, I'm going to assume that this is going to be dependent to a big degree on the actual resin you're using, but could you give us an idea of how long have you actually got to work with the resin before it's set up to a point or starting to harden to a point that you can no longer use it?
That's wildly variable. That could be a couple of minutes to an hour or even longer sometimes. If you're working with like prepregs again, like that, there's an out life, which is something could be out of the freezer for days, and that's still workable and still would be able to be cured. But it really depends. Yeah, that's a very wide scope question.
Okay. In the same sort of vein, I assume that your ambient temperature in your workspace is also going to affect the curing time of the resin, in terms of if you're in the middle of winter and it's snow on the ground outside versus maybe 35 degrees in the middle of summer.
Yeah, 100%. So that's another thing where you want to maintain a consistency as well. Like there's often manufacturer specifications which would tell you what your environmental conditions will or should be, and just stop having any moisture ingress or slow cures, which might affect the environment, can affect the quality of the cure as well. You really just want to standardize it as best you can. If you were to draw like a generalized figure out of it, 18 to 23 degrees Celsius is quite a common kind of range where you want to be operating.
That also conveniently works quite well for the human body as well. Not too uncomfortable working at that sort of 20 degrees C vicinity.
It does, yeah.
You've just used the term prepreg as well, and again, for those completely fresh to this, could you give us an understanding of what that term is? What is that product or material?
Yeah, so I guess the opposite end of the spectrum for what we've talked about the dry fabrics and we've talked about the resins by themselves. In this situation, the fabric comes pre-impregnated with the resin system. So you could almost just apply the fabric to your mold surface, and there's a bit of a process in cooking it off, but you stick it on like a sticker and cook it off, and then it produces your form, which it completely changes the way that you can approach a job. It's wonderful stuff.
Okay, I want to dive into that a little bit deeper, but first of all, in order to get the optimal strength to weight ratio out of a composite component, it really relies on having just the correct amount of resin on your fabric as well, correct?
Yeah, yeah.
So with traditional processes, which we'll talk about shortly, it can be, as I understand it, difficult to get that ratio optimal. I think probably resin infusion comes about as close as we can get, but then prepreg is another step again it's essentially impossible to achieve using those other techniques which we're going to go into.
Yeah, you're kind of right there. So we talk about kind of a spectrum, I suppose, of control. And the old methods like wet lay, where you're applying the resin to the fabric yourself, you should have a strategy to think about the application of your resin. But it varies job to job, person to person. So it's hard to maintain consistency there.
So you're talking about trying to be consistent in your approach as to how much you wet out the fiberglass or whatever the material is with your wet lay, how you wet it out so you're even with the amount of epoxy the amount of resin that's being applied.
Yeah, that's right. Yeah. But then at the opposite end of the spectrum, you have the prepreg system, which, as you say, it has the resin pre-applied to it, and that would be at a fixed ratio. And although there's methods of getting it out, you're not going to be able to put any more resin into the system. So you would be optimized for strength to weight, and there is the least amount of opportunity for people to make errors or introduce other variables, which you say if you're starting to really aim for the top tier stuff, you need it to be bang on and to be able to produce that consistently.
The other aspect with prepreg is the working time we've sort of already touched on with resins. While you didn't kind of give us a specific answer, there is a working time, it's limited. So if you're working with, let's say, a very complicated mold, and it's going to take you a long time to actually get all of the individual pieces of carbon into that mold, that probably lends itself better to prepreg where the cure time's not such an issue.
Yeah, that's right. So that's I guess when you're starting to look into structures, perhaps like of carbon fiber monocoque or things like that, where there is a lot of intricate details that you need to get right, and perhaps a series of processes that will take a lot of time. Having the opportunity to slow down and make it, as best you can. You as the operator maintain control of the job, whereas with the wet lay, the clock's ticking as soon as you mixed.
I guess we're sort of talking about these out of turn, but we will get into them in more detail. As you were saying that, I was sort of thinking to myself, probably resin infusion also would match prepreg in terms of you're not limited on your working time because you can lay out all of your dry carbon into your mold, get it vacuum bagged, and then once you're comfortable with all of that, then you can start adding the resin.
Yeah, that's right. So infusion has it's just a wonderful in between. It's very flexible, and you're capable of producing anything from low end to quite high end products with it. Again, it just still depends on what you're hoping to achieve.
Yeah, okay. In terms of what we've talked about so far, probably most people are thinking, well, we'll just go straight to the top shelf and use prepreg, but it's not quite that simple, is it? Generally, prepreg requires an autoclave for the curing process. I say generally, there are now some other options we'll talk about, but can you explain what an autoclave is, how you work with the autoclave and prepreg, and why that gives us advantages?
Yeah, so the autoclave is a large pressure vessel. So I guess where that would deviate from a regular job is that you bag it up and load it into this chamber and then charge the vessel up to perhaps anywhere between 1 or 6 bar generally for us. And then that allows you to fully consolidate the product and helps it evacuate some of the solvents and things that start to, I guess, come out during the cure process.
This pressure that's being applied, so also important to say it's pressure and heat, correct? This is kind of a big pressurized oven.
Yeah.
Is this sort of just going much, much further than what can be achieved for the pressure applied with vacuum bagging?
Yeah, so with the vacuum bagging, you're just the absence of atmosphere. So, 1 atmosphere is 14 psi. And with the addition of the autoclave pressure, you can multiply that several times, which if you think about mechanically, you're crushing down on this lattice of fabric overlaid. Eventually you get to the point where you have compressed that as far as it's really going to be compressed. But the trick comes with being able to get any of the voids and contaminants out of the resin matrix and get them into solution. Where if you hadn't done that, you might have other bubbles and things inside of your laminate during your manufacturing process. So that would be where it would, I guess, it produces, I guess, a quality product, which would, in terms of perhaps maybe its consistency and its strength and properties.
Does that also go as far as surface finish as well? Just what you're talking about there with getting sort of bubbles and voids out, is that going to mean that you're unlikely to end up with the little pinholes in the surface that would need to be refinished?
Yeah, it can do. But, I mean, you can still get very good results from other systems too. I mean, mold preparation is the real key there, I think.
Okay. All right. So it probably suffice to say that an autoclave is going to be outside of the budget of any home enthusiast, but there are also, as I understand it, out of autoclave cure prepregs too. Have you had any involvement with those, or at least can you tell us maybe pros and cons of that version of prepreg?
Yeah. So I've used some of those systems in the past. It is a cheaper way to get into it, and as you say, the setup costs are a lot cheaper. You could cure that in any oven, as long as you've got a decent control on your oven. That could be done anywhere.
What sort of temperature do those cure at, and I guess also what sort of temperature do prepreg and an autoclave cure at?
Again, that's another quite variable question, but there's ones that after the autoclave cure, I think the lowest I've seen is 70 degrees, which is wonderful. For a low tech oven, you could have a refrigerator panel oven or something like that. Just make a hot box or something. As long as you've got a good control system, you can manufacture some pretty cool things pretty easily with it. In autoclave stuff, I can only speak to the stuff that I've worked with, but starting from around 80 degrees. If you have the opportunity to go hotter, you generally do. There
must be an upper range to this as well if we start melting some of the vacuum bag components too.
Yeah, that's true. But you get different flow characteristics as well with the adhesive, with the resin in the system when you get a bit more heat into it. But for the upper range, 200 degrees is kind of the upper end of the spectrum, but your cures would often be in the low hundreds.
All right. Talking about the pressure, you mentioned up to maybe 6 bar in an autoclave. That's sounding to me as well like the mold design would have to be really thoroughly thought out, so you don't end up actually with that mold deforming under the pressure.
Yep, that's the thing too.
I mean, even that can be said for vacuum bagging as well, out of an autoclave.
Well, yeah, that's exactly right. So the rigidity of your mold is very important, and also the ability to resist the temperature of the cure. So I guess is another level again on that is that you'll have a coefficient of expansion, which will be introduced if you're using different materials. So you're going to have inaccuracies that you're going to introduce.
You see a finished part's not dimensionally where you thought it was at room temperature, perhaps.
Yeah. So if you're getting into the nitty-gritty to it, there's lots of little things that'll get you. So yeah, you get a lot of things to consider.
Sure. You also mentioned when you started talking about prepreg about pulling it out of the freezer. So suffice to say, the stuff is stored in a freezer. How long can it last outside of the freezer? So what's the sort of the use time of it?
Oh, yeah. So it'd be say 30 days.
Oh, okay. All right. Yeah. I guess on the same basis, I can only assume, never having worked with the stuff, you don't want to pull it straight out of the freezer and start working with it. It's going to be cold, and I'm guessing that would also make it less flexible.
Yeah, and then there's also the risk of taking on moisture into the matrix as well. So it's not exactly workable. If you pull anything frozen out, it's not. You can't unroll it off the spool or anything if it was like that. So yeah, it's not really ideal.
Yeah, I was making some bold assumptions, as I say, never having worked with it, but it sounds like some common sense actually does prevail even with prepreg.
Yeah, no. I mean, so if you would have a large roll came into the workshop, if you're taking it in as inventory, for example, you might separate it into 3 or 4 rolls so that, you can shorten your thawing time, and it means that you can pull something out first thing in the day, and then maybe by, lunchtime or smoker or whatever, you'll be rearing to go, rather than if you've got this big mass that needs to thaw out. And then, because, if you're introducing cycles to how many times you thaw it out and stuff, it starts to degrade it as well.
Okay. All right, well, we started at the top shelf and now we're going to dive into some of maybe the more achievable options for the average enthusiast. So you've already talked, I guess, enough about wet lay, where we've got the mold and we're just physically putting our chop strand mat or our woven mat into the mold and then literally wetting it out by hand using our resin and a brush. So that would be the low level, easiest to achieve, less technology and consumables required.
Yeah, pretty well. Yeah, and that's a really great way to get into it. And I think for most people that are interested in like motorsports or whatever, or perhaps just general car custom stuff, they're doing a curb or something with their body kit, and they'll need to do a bit of a running repair on the weekend or whatever. And you go down to your local auto body store or whatever, and get the goods, and you can get into it.
Okay. And just given what we've already talked about, so would I be right in saying there that the Pro is very easy, low cost entry. The con would be you're not going to have that optimal resin to weave sort of ratio, so strength and weight are going to be compromised?
Yeah, but I mean that you can still achieve some pretty good results by hand, but if you're perhaps just doing it off the back, you might not get the right technique or whatever. So that's operator.
But I mean, I guess also fair to say that if we're just getting stuck in and we're maybe creating our own body kit for a road car or a club level car, or maybe we're making some repairs, probably at that level, the strength to weight is probably not the highest priority.
No. I mean, getting out there and having a go and working on your skills that's the target there, I think.
All right, next step up the ladder, or at least I would say, in my opinion, this would be the next step up the ladder, would be vacuum bagging the part into the mold. Is there something in between? Does that sound about right?
Yeah, no, that's probably about the next step. Yeah, so we kind of talked about that a little bit in the theory of the autoclaving, but the vacuum bag has a similar effect, and you can also, depending on your methodology, you can control a few other things there too. But often it achieves a better result if you can do it. It's a good way to go.
Okay, so what advantages does it give?
So you can produce a pretty good surface finish if you can get everything nicely seated down and eliminating voids from the system.
So it does a better job essentially of pressing the material into sort of more intricate parts of the mold.
Yeah.
Right, but there's also the advantage in terms of getting closer to that ideal resin ratio.
Yes and no. This is another wildly thing. So the part of the process there is that you'll be putting a series of, like, we call them consumables on top of the carbon, so it's a carbon repair. So like that allows you to bleed resin out of the system, and depending on how you spec that will change how much resin flows out of there. And you can actually fully dry out a repair if you were to spec that incorrectly.
So you can go too far.
Yeah, so to say that you're making the resin ratio correct, that's not necessarily true. That's something that would come with a little bit of experience. But there's lots of different materials there that you can use to configure that to get enough flow for it to work, but also you don't want it to dry it out.
Okay. Can you explain what these consumables are?
Yeah. So quite commonly you'd see a peel ply layer, which it's hard to explain without perhaps a drawing. But like if you were to consider that you've got your body panel initially, and then you put, or a mold say, and then you put your carbon fiber fabric down to whatever stack you're doing, you'd now put the peel ply down, and that would allow you to have a fusible link, I suppose, in the system, that all the stuff that's going to go on top of the peel ply can be removed off the surface of the carbon easily.
So that peel ply's got this magical property where it doesn't actually stick to the cured part. You can actually, as its name implies, peel it off your carbon fiber component.
Yes. And it does have a couple of other cool tricks too. So it is a fabric in itself, so there is a little bit of ability to flow air through it and resin. And depending on when you release or peel off this ply, you can also use that as a method of surface preparing. So a surface preparation. So like often just because you've made it in a mold or whatever, doesn't mean that the component's finished. It might be like a multi-part assembly. You need to bond things together, but that's the first kind of commonly seen layer, I suppose.
That the finish that you get with that peel ply is sort of quite dry and rough, I guess I would explain it as opposed to what you might end up with a wet lay where you've got a surface finish of just resin. Is that sort of ideal prep for bonding it to another component, or does it need further processing before you can bond it?
Well, that's another good question. So what it does is it kind of fractures the surface of the resin, I suppose, on the surface, which chemically it's like excited, and it allows the free surface energy for an acceptable bond to take place at the chemical level. Depending on your shop processes will be, you may or may not have to sand it. You may or may not have to like use solvents and things like that to prepare it further, but that's a big debate there.
All right, so once we've kind of mastered the art of vacuum bagging, the next one up the ladder again, I think, would be resin infusion, which is kind of a bit of an adaptation on vacuum bagging. Again, did I get my order right in terms of complexity and finish?
Yeah, I think so. I mean, there's still, well, I don't know how deeply you want to dive into it. There's still a lot more consumable stuff that comes into it. But
in terms of resin infusion, I guess, as I see it, the advantage is you've got that ability to spend more time working on the layup, as I mentioned, we talked about earlier. You're not introducing the resin until everything's already vacuum bagged and in place. And again, as I understand it, we're kind of getting hopefully a little bit closer to that ideal ratio of resin to fabric. Although from what you just said before, maybe there's sort of a lot of grey in that area as well. Is that about right in terms of pros and cons of resin infusion, or have I missed anything?
Yeah, no, it's a good in between. It can be used in a lot of different ways. Things might be changing a little bit in recent times. I mean, the ability to purchase out of Autoclave prepregs has probably changed the argument a little bit more. Those products haven't always been as readily available as they are now, but there's time and a place, I suppose.
Could you give us maybe a quick overview of how resin infusion works? So once we've laid up our fabric into our mold and we've got to a point where we're going to put our vacuum bag on it.
Yep. So the way that I guess in principle is that you've got this bucket of resin at one end of the job, vacuum source at the other, and you will have the system would be sealed by a vacuum bag, as you say, and you would draw a vacuum through the job, and the resin would be sucked across the job, and it would wet out the fabric as it goes. You get to the end of the job and seal it all off, and let it cure under vacuum. And that's kind of just the gist of it.
Are there any dangers with resin infusion whereby you end up with voids that don't end up wet out by the resin? Or, I mean, I've never done this myself, or is that an impossibility? Is it pretty much bulletproof?
No, it's not. That's the thing is, well, I guess it's again, none of these things are bulletproof. And even like you could do the same job several times and you might have a little bit of variation, and things that on the infusion specific elements would be like perhaps where your vacuum source is, where your resin feed lines are on the job itself, that I guess you could say they are wrong. But I mean, there's just so many different variables there. And that would, that could potentially mean that you haven't wet out. You could go significant sections of the job that might not be wet out by resin, and that would be scraping the part.
Yeah, so I was going to say, suffice to say, there's no coming back from a part that's not been properly wet out.
Not really.
It's not like you can just wet out that dry patch, put it back in the mold, and hope for the best.
I mean, there's some ways around these things, but like it wouldn't be the preferred trade practice. Yeah, some of these things would be significant investments. Like you might be making a whole hull or something. You're going to have to try and find a way to fix that. That might be months of work. You don't want to throw that away, but if it's a small part, then you probably just scrap it.
Okay. I just want to actually come back one step. You mentioned before with vacuum bagging that you can actually extract too much resin from the part. How would we know that we don't have enough resin in the finished component?
You could, in the simplest of terms, I suppose you would weigh the amount of fabric that you were going to use in the job, and then determine the ratio that you're going to be aiming for. So and then weigh in the total part at the end. You'll see what you've got. And when you're talking about the infusion side of it as well, like you're going to have resin will be saturated throughout your consumable stack and all of your feed lines and things like that. So there's a little bit of other stuff that might need to consider there too. So that's where the test and adjust comes into it.
So, okay, two parts there. First of all, where would the average enthusiast who's sort of getting into this find out what the correct ratio of resin to fabric is going to be? Does that come from the fabric manufacturer or the resin manufacturer?
That would be, well, you're generally looking like 60-40 kind of ratio. So that's where, like, if you're thinking about it in like the hobbyist level and you're doing the wet lay, so, you might have, I'm going to use X amount of fabric and I know that the process that I'm going to do is going to be wasteful with resin. So, like cups and tools and things are going to have waste on them. So, like rather than going 60-40, I might go 50-50 or something like that, because I know that I'm going to bleed it off and I want to have access to it.
So in other words, for the resin infusion technique, you're not going to just mix up the weight of resin that should wet out that part, because there's all of that wastage, as you say, through the lines and the consumables. So you need to add some additional that's not actually going to make it into the finished part.
Yeah.
Okay. Is there sort of, in terms of surface finish of your part, let's say you want that sort of raw carbon look, you're not going to be painting it, so you want to try and avoid any sort of voids in the surface finish. Between the vacuum bagging and resin infusion, is one superior to the other in terms of that surface finish?
I would say that, well, they both are under a vacuum in a way. So the advantage of the infusion system is that you're going to have more time to set your fabric and go through the motions of and checking your bag, and because you're not going to proceed with a vacuum infusion unless your bag integrity is bang on. So there is the potential to do it much better with infusion. It's not to say that you can't achieve good results with just a quick wet lay or whatever, but it's just the process is structured in a way that you can, go over the fine details.
Yep. Okay. Are there any other processes that we haven't talked about so far that you think we should discuss?
I guess there's probably like just an awareness. There's automation is another thing there that is becoming more and more popular. It's not something that I've really done too much or had much to do with, but filament wound like tubes, and there's automated fabric placement, in big industry. That's just something that you kind of see.
So it exists, but probably not too relevant to motorsport?
No. I mean, certainly not at the hobbyist level, but you'll see lots of crazy things, but there's a lot of investment and critiquing on the process that, not necessarily you're not going to be able to achieve that.
One of the, I guess, potential downsides I see with the use of composites in the likes of a vehicle tub or monocoque, it comes around sort of repair to accident damage. How repairable is a component like a carbon fibre tub?
Yeah, that's again a difficult question to answer. The nature of a repair is that it's probably not going to have the same characteristics as the original. You try your best to be like for like, but it won't be. If you've removed, like you've chopped a big bit of accident damage or whatever, and as a result of it, there's a hole has to be chopped out or whatever. Like the fibers are no longer continuous through that area. Whether it's a scab patch or whatever, your workaround is there. So it's not going to be 100%, but you try your best to get it as good as you can.
So does this sort of come down to an assessment at an engineering level if a repair is even viable with retaining sufficient strength?
Yeah, depending on how highly strung the original item is, that the sacrifice that you make them with the repair might be too much and it might have to just be written off. But like if it's a very high value item, or perhaps it's not the end of the world, there's definitely ways around doing things. Yeah.
Okay. I also wanted to talk about sort of incorporating features into composite components such as, threaded mounting bosses or something of that nature. I don't believe we're really in a position where we could reliably drill and tap straight into a composite component. So how do you deal with that sort of requirement?
Yeah, as I say, like these parts don't exist in isolation, so finding a way to connect them into the rest of the system is really important. So quite often it would be like inlaid into the product itself. So you could use like metallic hard points or perhaps pieces of carbon, or depending on what the process is, maybe some hard foam or whatever, to give a durable.
Something that's going to just be stronger. So, I mean, I'm talking here, if people aren't picking up what we're putting down, if you imagine, most people have probably seen a photo or video of a Formula One carbon fibre tub, and obviously you've got all the suspension mounting points on it. So all of those suspension mounts and damper mounts have to go into something. So that's what we're talking here. You'd have a metallic plate potentially sort of moulded into the tub.
Yeah, that's right. Yeah, so with those structures, they're quite often sandwich structures themselves. So, if you look at a cross section of it, you would have a base layer of carbon fiber monolithic structure, and then you would see like a sandwich panel, and then that would be capped off with the monolithic structure. But at the same plane as the sandwich structure, you might see these hard points, which say could be threaded, could be through holes. Could incorporate other features altogether.
So there's obviously a lot of thought needs to go into the design element before you ever get close to pulling the prepreg out of the freezer to make a component like that. You mentioned sandwich there as well. So what are the materials that would be used as a sandwich between the layers of carbon fibre?
So I guess there's usually kind of two trains of thought there in the component level. You'd have your honeycombs, which would be like aluminium honeycomb and Nomex. And there's also foam is quite often used as well.
Okay. Strength or weight or cost advantages, disadvantages between those options?
I mean, there's like lots of different engineered foams, for example. So you can get some really high density foams. If you're going for a heavier structure, it can be really useful. The other handy thing about foam is that it can be machined as well, like its form. So if you have a interesting geometry, like you might want to have some crazy radiuses and stuff, you could pre-machine your foam to be pushed into the job when you're laying it up, which is a lot easier to do than machining the honeycomb. Honeycomb, can be quite problematic there, but then conversely, honeycomb's a nice way to have a low density sheet, over a large flat or flattish kind of area.
So just application specific, really, or application dependent.
Yeah.
Okay. All right, Keith. I think we'll move towards wrapping this one up, and as usual, we've got the same three questions we ask all of our guests. First of those is, what's next in the future for you? You've already had a fairly interesting sort of career trajectory. Composites is you for the foreseeable future?
I think so. I'm just kind of at the beginning of my career, really. So just continuing to learn and trying to develop the workshop. I really like to see the Rodin business succeed. So trying to put your best foot forward there and kind of lay a bit of a legacy out. Yeah.
What, I guess, to expand on that question, if everything sort of goes exactly how you hope, what's it look like for you 5 years from now? What will you be doing?
Manufacturing a few cars a year would be nice. And seeing our product out there in a motorsport environment more regularly would be ideal. Yeah.
Okay. Next question, is there any advice you'd give to a younger version of yourself, or maybe some of our listeners, to help reach you where you are today in your career faster?
Yeah. You kind of go off at a sweep floors and all that kind of stuff in the first instance, but I think a common theme would be that you just got to ask the follow-up questions. There's lots of opportunities where I've been really lucky to get some support from some mentors and things like that. And I think that, or job opportunities too, there's a lot of stuff that like anyone can go up and ask the question once. And some people just they might just be doing, I want a job or whatever. But like, if you go back there, year on year, and you remain in contact with these people and show that you've got a bit of growth in that area, and you're really dead set keen on it, often they'll pick up on that, and they'll see your interest, and they'll support you. I guess you can't expect to be given anything straight up, I suppose. That's what I'm getting at.
Basically, got to show that you've earned it. You're worth investing their time in.
Yeah.
Okay. All right, our last question for today, Keith. If people want to follow you and see what you're up to, how are they best to do that? So Rodin got some social media accounts, websites, etc.
Yeah, just the usual kind of business contacts there. So we're available online through the website, or just rodincars.com. Yeah, Facebook and all that other stuff too. There's plenty of YouTube videos recently. Yeah.
Okay. As usual, we'll put links to those accounts in the show notes so it's easy for people to find them. Look, thanks for your time today, Keith. It's been really interesting learning about your backstory and how you kind of got to the point you've got to. I've learned a lot more about the process of becoming a composite specialist, and hopefully everyone's also learned a little bit more about the different composites that are available and pros and cons of each. So we wish you all the best for the future.
Oh, thank you very much for your time.
I hope you've enjoyed this episode of Tuned In, and don't forget, by using the code podcast500 at checkout, podcast listeners can get a huge $500 off our VIP package, which includes over 40 current courses, as well as a long list of courses to be released in the future. As a VIP, you'll also get lifetime access to our members-only webinars and our community forum. Lastly, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Alex from Canada, who has said this is one of the best free resources out there on the internet. It's also a great way to keep me motivated and get me back out into the garage to work on my own car. Thanks for all of your great work, HPA. Well, thanks for your kind words there, and if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview, and before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.